What's up? Got a little record scratch going there. What's going on, you guys? K1GMM, Kilo 1 Golf Mike Steve, Vermont. The Green Mountain Mental Case. Hope you guys have been doing well. Been a long time. I'm going to try something, and it's going to be a mess. So I don't blame you guys for leaving when you see this. It's going to be quite the mess. So I'm going to show you how I construct the feed points on the loops. This is relevant to dipoles, loops, that type of stuff. And I'm going to show you how I splice together 50 and 75 ohm coax. Now the 75 ohm coax I use a lot of quad shield, RG6 quad shield. Now it has an aluminum braid. You cannot solder to it. So how do you connect it? There's two options. I'll show you both options. And this can be done with how I do it. It can be done with basically stuff you have. Any ham radio operator should have this stuff sitting around. And I'll show you, I'm going to actually do it in real time. And it's going to take a while. So you guys feel free to carry on with your day. I don't have the chat up. I don't know who's in here, if anybody. But I will have the chat up over at the workstation. So without further ado, I'm going to jump over there and we're going to start that process and we'll go through it together. I'll show you how I do it. Now, I've never had a feed point failure doing it this way. I'm a big fan of hard connections. PL259s, SO239s, I stay away from it if I have to. I'll show you how I do it. You do it obviously however you want. You may have a better way of doing it. But I've never had water ingress. And I never had a feed point failure after doing it this way. And it's very simple. It ain't pretty, but I'll show you when I get over there. So let me get the other camera on and I will make my way across the room. And I have to grab the microphone. Sorry about the noise, because you're not going to hear me. So I'll place the microphone over here. And I'm going to lay it on a towel. There we go. Okay, I've got audio. I can see it. All right, so let me get the chat up, and I'll say hello to you guys if there's anybody in here. And there is. My goodness. All right, I will pop out the chat. I will close this. And let's see who's in here. Okay, Tantillo, what's going on, Eddie? I am alive, can you believe it? Hey, Martin, how's it going? 9 Alpha 3, good evening to you, Tantillo. Been a long time, I know, dude, I'm sorry. Electro Gaming, Jerry, you animal, what have you been doing? Stan, congratulations. Quick shout out, Lester, good to see you. From Wales. Oh, life hacks. Oh, we didn't do a life hacks. Let me go get it. Thanks, Ed. Hey, what's the date, anybody? What's the date today? Anybody know? What is it, the 11th? Yeah, it's the 11th. Oh, man, I'm off. I'm off on the life hacks. So here we go. I think you'll be able to see it. Okay, take a great selfie with your pet by putting a treat on top of the camera lens or holding it in the same hand as a camera. Oh, great idea. There you go, man. Sweet. Northern Dawn, Tuesday, thank you. Yeah, I've been so busy. Lofty, how's it going? M7ACZ. A big congrats to all the upgrades that have taken place. Bear. He's in the stream off and on. He just got upgraded to general and he's studying for his extra. There's some new tickets that have guys that have gotten their tickets. And big congratulations to you guys. Even if you catch this later, It's still valid once it renders. K1GMM. Brian, what's up, man? From Michigan. Yeah, so we're gonna roll through how I put together the feed points. All right, so I'll keep track of it. If you have a question, stick it in the chat, and I'll try and answer it. It's really self-explanatory, but okay. If you don't have any of this, get some. Just cutting board. These are scrap pieces of cutting board I have. It's one of the ham radio operator's best friends. Zip ties. You need something like liquid electrical tape. Something like that. Okay, of course you need some solder, flux, cutters, razor knife, soldering iron, a few different drill bits, cordless drill, and that's pretty much it. Okay, so the first thing I'm going to do is I'm going to show you how I build the feed points, okay? Now, this is just a scrap piece. I cut them actually as small as possible because if an antenna is hanging and swinging in the breeze, hey David, how's it going? Good to see you and welcome to the madness. A lot of hacking's going to happen in a few minutes. So I try to keep these cut them down as small as possible. Because remember, when they're pulled up in the wind, something like this doesn't seem significant, right? But as the wind blows, it will get a thrashing. You get a 40-mile-per-hour breeze. This is nothing but a sail, right? So don't be ridiculous about it. You know, for like a feed point, I'll probably cut it about like that. About that much of it. So, but I'm going to just use this as scrap right now. So first thing you want to do, all right? So I'm going to simulate an antenna first. So I'll cut this wire. All right. So this is 12 gauge. I use a lot of 12 gauge stranded and 14 gauge stranded. A lot of my antennas are actually solid core. So the first thing you want to be concerned about is strain relief, right? How do you keep, and this is for all the new guys that have just gotten into the hobby and they're like, well, how do I build a feed point and how do I keep it from coming apart? Well, I'll show you how to do that. Remember, as the antenna's pulled up, right? It's pulled up under tension. It's going to try and pull, let's say it's a dipole or whatever. You're going to have it under tremendous tension, right? So you've got the coax coming into the feed point. Well, how do you keep it from pulling apart? To a lot of you, this is stupid stuff, but it's important. So the first thing you want to do, match your drill bit size to the wire. Find a drill bit that it can be a little bit bigger than the wire diameter. All right. That is, I think that's about the same diameter. Let's see what I got here. Is this bigger? That's not bigger. What about this one? That'll work. That's good. Okay, because I do use different wire. I think that other bit was for 14 gauge. So, and I've got my beer. Cheers. And no, I didn't cut my hand like Callum did. That's coming. All right, so you need to create the feed point, right? So what I do, you got the two legs of the antenna, one coming in this side, one coming in that side. So what I'll do is I'll punch a hole. There's already a hole here. So punch a hole here. Punch a hole here. Make sure you don't drill through your freaking hand. All right. You want to do the exact same thing for the other side. So I already have a hole here. So let me open this up. You want to drill them at an angle. All right. And you're asking me, why are you drilling two holes? I'll show you. And this ain't pretty. I'm going to make a wicked mess, all right? So what you do, your wire comes in from one leg, right? Comes in one hole, goes through the back, like so. All right, now you want to, you can strip the wire first if you want to. And no, I don't have, my strippers are upstairs. Okay, so strip the wire. Bring your other wire in from the feed point, or from the antenna. This is your other leg. This can be done with any plastic, but you want it rigid enough so it doesn't move. You don't want this feed point to move, and I'll show you how to stabilize it. If it moves, first of all, it'll break the weather seal, and I'll show you how to seal it. And second, it'll break the connection. I went through hell trying to figure this out, how to do this. Now, a lot of guys use 239s and 259s. Fine. If that's what you want to use it. Me personally, I'm not a big fan of them. It's basically a spring-loaded connection. It's not a hard connection, and I love hard connections. Okay, so here's your feed point with your two legs of the antenna, right? Now what you got to do is you got to get your coax to it. So you got your length of coax, right? This is your feed line. Oh, I need more beer. I've already stripped this, and I don't know if I'll be able to get it through the hole. But you want to strip your wires. Okay, expose the center pin and the shield. Now what you need to do, you need to match up a drill bit for the diameter of the coax. That may be a little, boy, that's borderline. I think that'll work though. Okay. So basically what you're going to do is you're going to do the same thing with a coax, but a little different. And I'll tell you why it needs to be a little different. You're going to punch two holes in this. Now you can't just go straight through with the coax like you did with this, and then back up through and then up to the feed point. Because what will happen is the cutting board will crease into the coax and it'll pinch the dielectric down, and you'll probably end up with something weird happening. Yeah, I got a very dull drill bit there. Yeah, the peanut gallery's in session. I can see Ed's already started. All right, so you want two holes coming up to the feed point. So you spank a hole through the bottom. All right, you want them spaced out a ways. Okay, what you want to do is you want to chamfer the hole now. Okay, so your coax is going to come in this side first, and then it's going to come back up through here to the feed point. So what you want to do is you want to put the drill bit in like this and tilt it. Pry it over. I don't know if you guys can see this, but what it does is it allows the coax to come in at an angle without a sharp edge. So it's not trying to bend the coax at like a 90-degree angle. That's what you want to do. Okay, next one. You want to go opposite on the next one. Okay. So this way. So this way now. Bring it right down. Don't let that drill bit slip out. You'll freaking catch your finger. And you'll be crying home to mama. I'll probably have to cut this off because it ain't going to sneak through there. Okay. Take your coax. She going to go through? Oh, yeah, she goes through there. Okay, bring it up. Nice big loop. Stick it through. Bingo. And I will tell you how strong this is. This will scare the hell out of you. I hung an antenna in an apple tree a year ago, and I must have put, I would say, well over 100 pounds of tension to rip it out of the apple tree, by the coax. I was holding on to the coax, I couldn't get it out, and I couldn't drop it down. It was all tangled up. I ripped it out with a coax, and it did not break the feed point. Okay, so now what you want to do is you want to take your center pin, bend it over to that side, okay? And what you're going to do is you're going to adjust your wire length. Remember, your antenna wire is cut for a certain length. Where's my freaking... Oh crap, they're upstairs. I'll try and use these. It helps if you have a pair of needle nose pliers. So you want to get this in here so that it comes over and lays up against, and I forgot my clamp, damn it. Wow, I forgot a bunch of stuff. What I usually do is I clamp this down to the table so it can't move. I knew there were things I was forgetting. Okay. Okay, so you want to line your wire up. I'm going to get the soldering iron on. Excuse me. And usually you can tin it if you want. I usually do tin the wires prior, but I'm not going to right now, just for giggles. I would tin it first because when you re-hit it, the wires just bang, they go together. So what I mean by tinning is go ahead and pre-solder. Just get the center pin soldered up, get it coated with solder, and get your antenna wire solder on the antenna wire. When you hit it with heat, they'll go right together. You don't have to heat the metal. You see what I'm saying? The actual copper. Come on, baby. So you can basically solder these together. Come on, what are you, sleepy? There it is. Oh. Make sure your tip is clean. And there you go. Flow it onto your center pin. Make sure it's not cold. And you're done with that. So now what you do is you pull you want it tight. You won't have to work it. Okay, so that's done. Now what you can do is you can do the same thing to the shield side, all right, with this side. Wrap it up on here, solder it together. But your question to me is, and that'll be done. So the last thing you really need to do is, there's two things. So once you get the other side soldered up, I gotta get this, yeah. Again, you want it tight, man. So there's virtually no way you can pull that connection apart. No way. And I'm pulling, that's probably 30 pounds, 40 pounds of pressure right there. It does not move. That's what you want. No movement. So next thing, okay, what you want to do now, you want to put a hole right here next to your dielectric. There's already a hole in there. See that hole right here? So I'm not going to drill in. You need 2 holes, 1 on each side. So slam a hole through there. 2 holes, 1 on each side of the dielectric. Show you why. Just kidding. Take a zippy. Gonna need 2 zip ties. Take a zippy, put it down through the hole. Put it up through the other hole. Zippy in the hole! Okay, take your thumb, press down on the coax, flatten that sucker right out, bring it right down. Okay, there you go. That connection will never move. All right. Now this side, you can either solder, if this is like standard 50 ohm coax, you can solder the braid straight to the element, okay? You're gonna wanna pull this one down too. So what I usually do here, I solder it first, but because I'm gonna kind of kill 2 birds with 1 stone, what do you do if you're attaching a 75 ohm matching stub? Who else is in here? Alexander, what's up? Hey, Steven. You see me just punched a hole through my hand. So what do you do if you're, like here I use a lot of 75 ohm coax. This is actually 75 ohm quad shield. And I use them as matching stubs to the loops. You have to. Now you can't solder to this, so what the frick, how do you connect your shield side to the other side of the antenna? Ta-da! If this is good enough to keep you from burning down the house, this is good enough for an antenna. I don't care what anybody says. Never had one fail. Take a little bit of dielectric grease, put it in here, take your antenna wire, yeah, a little too far. Would help if I had a freaking clamp. Can't believe I forgot it and I'm not running upstairs to get it. Stick this on here. I find the orange wire nuts work great. Spin it on there until it's so tight you cannot turn it anymore. Done. Pull the coax through, or pull the antenna wire through. Because what you want to do is you want to keep it away from that center pin. Pull it through so it's tight. And that's it. Take a zip tie, punch 2 holes. Take another zippy, down through, back up through the hole. Let's try that again. How many times do you put a zip tie in something and you have it backwards? Anybody ever do that? I do it all the time. Pull it down nice and snug. Excuse me. Here's a little tip. How many people have gotten cut on... How many people have ever gotten cut on a cut-off zip tie? My advice to you is never cut a zip tie off. Take a pair of pliers. Grab the zip tie about a quarter inch from the actual hub on the zip tie and twist. Twist, twist, twist until it breaks off. Never a sharp edge on that zip tie. It will never cut you. Just a little tidbit of information. So there's your feed point. Oh, crap, almost knocked my beer over. One more. One more you got. Got two more holes, one on each side of the coax at the very base. And I would use a bigger zip tie for this. This just puts the icing on the cake. Seems like a lot. If I wasn't doing this for you guys, it would have been done in half the time. But zip tie right here on the coax. That's it, baby. Freaking bomb-proof. That will never come apart. You'll have to tear the coax in half or break the wire. And I don't know if you've ever seen how strong 14 or 12 gauge wire is. I challenge you to break it. I can pull my tractor with this, and that's over 800 pounds. Lastly, take some liquid electrical tape. Use it liberally. Put it all over this connection area. Multiple coats until it literally seals down over the cutting board. This entire section needs to be sealed with that. And to the point where you don't see any wire, no strand, no braid, no nothing through that liquid electrical tape. Let it set and it will be there for years. You will never have water ingress if you do it this way. The reason why it won't ingress is because this connection never moves. It can't move. Where you get water ingress is where the connection actually moves and it breaks the seal. So you don't want that to happen. So that's it, man. That's how I do it. Now, I'm going to cut it apart. No, don't cut it apart. I'm sacrificing my precious zip ties for you guys. You do realize that, don't you? Okay, the heck with the feed point. That's out of here. Alrighty then. Okay, so you want to do, let's say you've got a 50 to 75 ohm splice you have to make, right? So you got to do you got your 50 ohm feed line. Don't freaking kick the soldering iron on the floor, you cheese ball. So let's say you've got a connection you need to make with 75 ohm stub, right? I'm going to cut this in half. So you got your 75 ohm stub, right? Which is going to go up to the feed point. All right. So this goes to the feed point of the antenna. And you got a piece of 50 ohm feed line that you have to connect to the stub. Well, there's two ways you can do it. Now you're asking me, well, what the heck is a stub? What's the matching stub? Well, the matching stub, let's say you're running a single element loop and you want to make it monoband, right? Hey Chuck, how's it going? And you want to monoband the loop. Well, you need to match that. And that's usually done, easiest way to do it is with a piece of 75 ohm coax. The problem is how do you get the 75 ohm coax to the 50 ohm coax? The 75 ohm coax goes up to the feed point of the antenna. This is your stub length, your stub. This is hypothetical, okay? This isn't exact. How do you get them connected? I'll show you exactly how I do it. Cut a very thin piece of plastic cutting board. There's two ways. Let me show you the other way first. Take a PL259 and put it onto your 50 ohm coax. Okay. Take a PL259, put it onto your 75 ohm stub. Then, so you got a PL259 on your 75 ohm, PL259 on your 50 ohm. Easy peasy. Take a barrel connector, stick it on there, put them together. Creamy. Seal it up, and you have your connection, right? Let's say you want to get the antenna up and you don't have a freaking barrel connector. And you don't have enough 259s. Well, how can you do it? Same way. It's not rocket science. I do it all the time, and it works. Never had an issue. So you got your cutting board. Drill a hole like I showed you. But you're going to have to drill two more holes. So you need a total of four holies. All right. So you got one hole here. I'm going to have to move that. So let's go through right here. Whoa. Okay, so remember, you go through the opposite way. Tilt the drill over, chamfer it. Chamfer that sucker. Okay, now you got to bring... Did I just do that wrong? No, I didn't. I'm looking at the wrong hole. So your 75 ohm to your antenna comes in here, right? Now you got to get your 50 ohm in here. So let's punch a hole. And again, make this does not have to be wide. It only needs to be about that wide. Just a strip. That's it. You don't have to get freaking crazy. Let's go another hole right here. Okay. So you need to figure out how the coax is coming in. So this is going to be where the connections are made, right? So this needs to go through here like this. Tilt the bit. I would suggest cleaning it up a little bit. I'm not, because I'm just showing you how I do it. Okay, remember this one's the opposite way because it's threading through. Tilt it over. Remember, you don't want to pinch that freaking dielectric. If you crease the dielectric, you kink it, it may affect the way the impedance of the coax or something weird could happen. So you just got to kind of use your head a little bit. Okay. 50 ohm. 50 ohm through. If you want to use 259s and barrel connectors, nothing wrong with that whatsoever. Nothing. Absolutely nothing. Pulled it through a little bit too far. There we go. Okay, got your 75 ohm to the feed point of the antenna. Try not to crease it. You don't want to crease this stuff. Make your loops as big as possible. Alrighty. Try not to get stuck with it either, which I'm going to. If you don't have strong hands, you'll end up with strong hands. Not that mine are strong. They're kind of Sally-ish, but yeah, there you go. Okay. So, one thing you want to watch for is any braid, any loose braid. If you have any loose braid and you don't catch it, you're going to pay for it because you get all the connection done and you'll have a dead short somewhere. So make sure you do it with a lot of light and you look really close. Like I can see some braid floating around here. Okay, so I've got too much dielectric on here, so I need to cut some of this off. So pull off some of the dielectric. That looks pretty good. Alrighty. Cut off the excess center pin. Alright. What you want to do is you want to get these center pins right up against each other. And you want to basically weld those suckers together. Here we go. And that will do her for that. Oh, good heavens. Where is it? Again, if you want to tin it, but I'm not because I'm going to just destroy this and rip it apart. I would tin the connections first. And just solder them together. And unfortunately, I'm not going to have enough shield to connect this. So I'll have to show you a different way to do that. Now remember, you can't solder the shield of the 75 ohm to the 50 ohm because it's aluminum. It's aluminum braid. So I'll show you how to deal with that. Kind of the same thing as the feed point. Waiting for the soldering iron. Need a beer? All right. Put the soldering iron on it, let it heat up for a second. Use high heat because the dielectric, high heat and speed. You want it to heat up quick. The slower it heats up, the more heat that's going to be transferred into the coax, into the dielectric. So if you don't have a hot soldering iron, get one. And that's it. That sucker's going nowhere. So, okay, that's done. Now there's a couple ways you can do this, all right? You can use a crimp. You could take a connector, spin this up real, in the shield doesn't matter, just to let you know. It doesn't matter that it's exposed. It's just a shield. So if you want to nitpick, fine, nitpick, but it's not going to make a damn bit of difference. So if you don't have enough shield, right, you're going to have to crimp these together. So you can either use some type of a crimp, slide it on, and then slide this in and smash it down. I don't like those. The reason why, I've had more of that crap come apart on me than it's a pain in my ass, and it just doesn't work. So what I usually do is, because I'm using 75 ohm, I can't really show you, but I will solder a wire, okay? I'll cut the shield back, solder a wire onto the shield of the 50 ohm, okay? Like a pigtail. I'll bring this over, and I will literally wire nut this. Put a little dielectric grease in there. Spin it down so it's so freaking tight you can't turn it anymore. Just like that. It won't come apart. Take that wire and solder it to your shield. Okay, that's one way to make a hard connection with 75/50 ohm coax. Simple, just like before. Two holes, zip tie it down, zip tie the other end of the coax down, zip tie the dielectric feed point down, cover it with this liberally. It will never fail, it will never come apart. You'll never have water ingress, and I can't even come close to moving that connection. So there you go, 75 to 50 ohm. If you don't have a barrel connector, you don't have 259s, you don't want to deal with spring-loaded connections, there's a way to do it. That's it, baby. Look at the chat, and then I'm shutting down. Figured I'd show you guys that, and you can get a good laugh. Brian, if you known, like I said, there's probably a dozen ways to skin this cat. And I'm sure there are better ways to do it, but like I said, we get 100 plus mile per hour winds here. I've never had one of these come apart nor fail because of water ingress or lack of strain relief. Remember, if you've got your feed point, right? Let's say take this apart. Remember the first one I did? You got the wires coming in on each end. Punch a hole through the center and put a piece of paracord on it, and there's your suspension. This is a hack way of doing it, but if you think about it, it's better than it's better than any connector, period. Remember, a 259 and an SO239 are spring-loaded connections. They're soft connections. Your center pin is riding in a spring-loaded connection. It's not solid. This is solid. This is better. I don't care what anybody says. You can't prove to me that this is inferior to this. This is pathetic. Look at an SO239 and look at a barrel connector. These are spring-loaded. Basically, there's a chance for condensation if it's not sealed properly, oxidation, buildup. These are not soldered together. These are. That's my point. That's what I wanted to show you guys, get you thinking about that stuff. Is it anal retentive? Hell yeah. Is it necessary? Hell no. But if you want to put it together and you want it to stay up there, and you want it to stay together and never have to fuss with it ever again, there you go. It's dumb. I know it's so stupid, it's dumb. But the reason why I tell you guys this is because I struggled for months with connections breaking on me constantly. And the problem with solid center pins, right, is as the wind blows, right, as the wind's blowing, that coax is constantly moving. Now you can take this coax and you can go like this. That feed point never moves. Never moves. And what was happening on my connections was that feed point was shifting just a little bit. It was just working back and forth just a tiny bit. And RG11, which I don't think I have a piece of it here. I use a lot of RG11. This is LMR 400. RG11 is the same diameter as LMR 400. Solid center pin. All you have to do is bend this back and forth a couple times, the center pin breaks right in half. So that's my point. However you do it, however you figure out doing it, immobilize the feed point. It cannot move. If you figure that out and you get it sealed properly and you make it as hard connected as possible, it'll work for you. Another reason I'm not a big fan of these is because I've heard of guys pushing 1500 watts into antenna systems with 259s on them, and they literally smoked them. They melted the dielectric right out. And I don't know if there's something wrong with the antenna. You'll never hear of that happening like this, with something like this. I'm not a big fan. If you're on power, screw this stuff. This is junk. It is, it's junk. If you're running a lot of power, and think about it, this is not a very good system for transferring energy. I mean, for crying out loud, yeah, it's a 50 ohm connector theoretically, but you might as well go to the hardware store and buy a friggin' 3-prong plug and plug it into your antenna. Think about it. It's the same freaking thing. The only difference is the shield is a thread-on shield, and guess what's prone to coming loose? Yeah. As it works and it swings in the breeze, sometimes these will actually become a little bit loose, and you just need a little tiny break in that connection for it to fail. This will never fail. And you're thinking a wire nut. How the heck would a wire nut work? Like I said, if it's good enough for your house and it doesn't burn down the house, it's good enough for an antenna. That's my point. Adios, you guys. We'll see you later. I figured you'd get a good kick out of that. Oh my God. I can't believe I did this and I put that on YouTube. Anyways, see ya. Al, what's going on? Yeah, hardwired. Hardwire the crap out of everything, man. Just take the time. Just eliminate any heartache and headache down the road. Stan. And, you know, you guys come up with a better way. You'll probably, that's why I throw this stuff out there. I'm sure there's better ways to do it. But, you know, I'll give you something to think about. Anyways, I'll be back later. Get back over it, kick over to the other station there. And, sorry about the noise. Don't I make a nice mess? All right. Any news? Anybody got their ticket that I haven't come across? I will get let me get the chat up on this computer over here. Haven't been on the radio at all. Looking forward to getting on the radio a little bit. Whoa! Whoa! Sorry about that, you guys. RG8X or LMR 400 depends on the band, Brian, and depends on the run. Let me pop out the chat here. Close this down so I don't kill the stream. Oh God, Chuck bought a new radio. I'm frightened, dude. What'd you get? Don't tell me you bought a 101D. I'm gonna be pissed. I want that rig, but I refuse to spend $4,000 on a radio. 3,000, yeah, maybe. But that is, yeah. I have a feeling you got a 101D. You better not have, or a new Kenwood. 890. Brian, RG8X or LMR 400? Okay. A good grade of RG8X is adequate 10 through 160 meters, depending on the run. Oh, 991A. Ah, cool. All band, all mode. Oh, J-pole? Okay, so you're talking 2 meters, right, Brian? Okay, so if you're running about 25 feet of it, you'll never see the difference between 25 to 50 feet. You'll probably never see the difference between RG8X and LMR 400. If you're running more than 50 feet, yeah. I'm going to put it in the chat here. On 2 meters, the loss can be fairly high really high on RG8X if you're running more than 50 feet. If you look at the dB loss, it's pretty substantial. If you have no more than I would say a 50-foot run, maybe 25, 30, 40 feet, just run 8X. But once you get out over 50 feet, pushing 100 feet, yeah, you're going to need LMR 400 if you want maximum fire and maximum receive. So Amazon has very good RG8X, a lot of ham radio operators. The stuff I use it a lot here, especially on the longer wavelengths. It's every bit as good. They've tested it on analyzers, and it's every bit as good as high-end commercial stuff that you get from like DX Engineering, HRO. I get my LMR 400 from Jafatech. Look it up, Brian. Jafatech LMR 400, cheapest, probably. I don't think you can get it any cheaper, and it's a big government contractor. A lot of ham radio ops use it, and it's dynamite stuff. That's what most of my stuff is running on here, because for like $60, I can get 100 feet of it, and that's cheap for LMR 400. So there you go. Why are you going to pay $100 for 100 feet of LMR 240? Or lesser coax when you can buy LMR 400 for $60? That's imbecilic. Just run the 400. So I figured I'd throw that at you guys. I think that's it. That's what I run. I actually run homebrew copper J-poles here, Brian. One on the All-Star node here and one in Arlington. They work really good. Mine are, if you type in a build plan for a copper J-pole, 2 meter copper J-pole online, that's basically when I run here. You can slap them together in, 15, 20 minutes. And they work good. They're not a smoking gun, but there's a lot of skin effect on a copper J-pole. It's a good radiator, So, anyways. I know, right? Callandy's been going wild on 2 meters. All right, you guys, if you got nothing more, I'm gone. I am the master hacker. I put myself out there on this one. People are going to see that, and they're going to crap a load. They're going to be like, oh my God, that guy is a mad butcher. And I don't care, because it's me. Don't put yourself out there if you don't want to get made fun of, and I know what it is, man. It's pretty scary, but it works, and give you guys, especially the new guys, a way to do something. See you later, Tintillo, and I'm gone. Have a good evening, you guys. I'll be back around later. I'm going to run the radio in the next couple days. 7-3. Bye.